All right, so a couple of months ago, Colt asked if I would come give a talk tonight. It was much later that I found out that I was supposed to talk like a pirate. On the other hand, it was also later that I found out that I was going to be giving a talk at an HTML and web conference. And I'll just say, screw it, because tonight I'm going to talk about Android, and I'm not going to talk like a pirate. So, on with the show. So I want to talk about tools of the trade in Android performance and pirate craft, and also some tips and tricks. If we have time, I have some demos, a little bit of case studies we can run through. I'm going to have to talk pretty damn fast to get there, so we'll see how far we get. If you are a pirate, obviously you need some tools to accomplish your job. You probably have a ship. You certainly need a chest for all that booty you're going to pick up along the way. Everybody needs a parrot. And then you probably have some enemies that you want to slaughter along the way in various ways. You probably also, I mean, it's a wooden ship. Maybe a screwdriver comes in handy and a hammer, and of course a chainsaw. On the Android side, we have some useful tools as well. First of all, we should find out how many Android developers are here. Android developers, go. Okay, not as many as I hoped, but more than I feared. So, we'll talk about some tools that maybe the rest of you haven't heard of before, but when you get to Android development, and I will say when and not if, then maybe you should be tuned into what these tools are. First of all, we have TraceView. This is your basic profiler. It tells you where you're spending time in your application, and it tells you the call stack of how you got there. It's a really good way of understanding the call flow and the expensive routines, the bottlenecks in your code. One thing to be aware of with TraceView is the exercise of instrumenting your code on the fly means that method invocation is more expensive than it would be otherwise. So it will give you a really good idea of how much time you're spending relatively in your code, but not absolutely in your code. So don't take the times for granted, but instead just sort of understand where the bottlenecks are relative to other things going on in your application. Next tool, Hierarchy Viewer. This is an awesome tool that we use a lot on the Android team to understand what hierarchies look like. Most times we use it and pop up an application like, let's say, the Play Store, and we understand how horrifically complicated view hierarchies are. And it gives us a really good idea of what to tell people to do, which is don't use so damn many views. Because the more views you have in your application, the more time we take to actually draw them on the screen. Even if they're hidden off screen somewhere, we still have to run through the hierarchy and process information about them. So this tool will give you a nice visual representation of what's going on with your hierarchy. If it's too small to see over on the right there, you see a really flat hierarchy with tons of stuff spooling out to the sides. That's maybe an indication that you could go a little bit simpler. It also gives you a good idea of what the properties are in the views at runtime, so you can poke into any of those nodes, see what it looks like, and see properties like, is it invisible? What's the alpha value in that thing? What are the layout parameters? It's a good way to debug the runtime situation of your code. Very useful tool. There's some caveats with it. You need a user debug or an eng build to use this thing. Otherwise, you need to use something called View Server. Look for it out there. It's available. It's a little bit of setup in order to use this tool, but very worthwhile. Tracer for OpenGLES. This came online in, I don't know, maybe ICS timeframe. Really good for game developers who use OpenGL. Also good to understand what the graphics commands are that are happening underneath any Android application. It'll basically show you all of the commands that we're spitting out to the GPU, the OpenGL commands, and it'll show you what the textures looked like at that time, what the programs, shaders, the state of basically everything going on in the GPU at runtime for every single frame. Very useful hardcore debugging tool, performance optimization tool. Another one that came online in, I don't know, maybe Jelly Bean, Systrace. This is awesome. I'm going to show a little bit of output from this later as well. This is a really complicated tool to understand, but it's worth your understanding it. When we worked on Honeycomb, the 3.0 release, we kept banging our heads against our desk because we would be running an application and it would stutter, and we would trace through the application, try to figure out where the time was going, and it was clear that the time wasn't going to that application, it was going on to something else going on in the system. And we always wondered, well, how can we find out what else is going on in the system to cause this hiccup in the application that I'm trying to tune right now? And this is that tool. It shows you all kinds of different output. You have options. I want to see the view hierarchy. I want to see input. I want to see vsync. I want to see CPU information. All this information about what's going on system-wide, so you can see how your application and how your animations and frame rate is fitting into the rest of what's going on in the system. So a very high-level tool. It's not showing you the entire call stack, but it shows you some really interesting elements of how you got into that particular bottleneck in your code. For example, if you're running layout during an animation, you're going to see it called out in really long draw calls on every frame and layout information on every frame. It's a good performance analysis tool for all kinds of situations. You can also use some tools that are built right into the device. You don't even need an IDE for this stuff or the monitor tool. Instead, you just enable these things on your phone. So we have profile GPU rendering. This one's available from developer options. Everyone knows how to get developer options, right? Tap 7 times on the build. It's awesome. It's the best Easter egg ever. So then you enable developer options, and it gives you a little toast saying, congratulations, you're a developer, and that's how you know you are awesome. So profile GPU rendering is one of the many developer options you can enable, and this will show you in real time the graph of frame rate. So it'll show you this little green bar at the top, which represents 60 frames a second, and then the histogram at the bottom shows how close to that bar you got. And smaller is better, right? We want to spend less time every frame because once you pop over that green bar, that means you caused a frame of jank. You hiccup for a frame, the user probably noticed it and had a bad time. So another tool that's enabled on the device is Overdraw. This came online probably in Jelly Bean. It will show you with color depiction, a couple other options. If we have time at the end, I'll show a demo of this. You can see how many times you're drawing each pixel. This is really important because it takes time for the GPU, for the entire system, to draw each pixel on the screen. Obviously, it's doing some work, right? That means every time you redraw that pixel, it takes a little bit more time. So if you have a situation where, let's say, there's a background on your window, and then there's a background on your layout, and then there's another layout on top of that that has an opaque background, and then there's a button sitting on top of that that's opaque. The pixels that represent that button were drawn 4 times. If all you're seeing is the background of the button, why did you draw the rest of those things? Right? So there are ways to optimize that. I'll get into that a little bit later. Overdraw is a really good thing to watch for in your application. If you notice that you're not getting the performance you think you should, if you're using the previous tool to see what GPU performance and frame rate is like, and it's not as high as you think it should be, check your overdraw. This is a really big time sink for a lot of applications. So let's go through some tips and tricks. So we have tips and tricks for pirates, obviously, and we also have tips and tricks for Android programming. So don't wear your pirate in a sword fight, or you'll have a bad time. On the Android side, let's avoid overdraw. We talked about this already. GPUs are terribly fill rate limited, and this depends on the device. Some devices are better than others at handling fill rate, but in general, you want to overdraw as little as possible. So we'll get into a demo. I think we'll have time at the end to see a little bit of that, and you can see what I'm talking about. Don't bring a cutlass to a musket fight, or you'll have a bad time. On the Android side, use hardware layers. So every time we draw a complicated view hierarchy, we're going to issue commands to the GPU that represent every little piece of that. We're going to draw an opaque background. We're going to draw a shadow. We're going to draw some lines. We're going to draw some text, some bitmap, some NinePatch, all this stuff that has to render for a complicated view hierarchy. That's all great if you have to draw it. But let's say you have that complicated view hierarchy and you want to fade it out, right? You're doing a transition to a new screen and you want to nicely fade that thing out. We're going to issue every one of those tiny little commands on every frame. Wouldn't it be nice if you could just do all that complicated rendering once and then a simpler operation every time we fade it to a transparent representation? Well, you can do that with hardware layers. You can say, I want this thing to sit in a layer, and then what we're going to do is we're going to draw everything once into that layer, and then every time we go to fade it out on every single frame, all we have to do in the GPU is copy a texture with a little bit of alpha information to draw at the correct translucency. Way cheaper. So enable layers. Very importantly, there's a demo at the end. I don't know if we'll get to. Very importantly, don't enable them full time. Don't just set layers on your views because Chet told you that's a good idea, because he didn't. That's not what he said. Go back and watch the talk again. Layers are really good for animations. They're very good on a temporary basis. But 2 things about them that are bad to keep around permanently. One is that they take up as much memory as they are large. That's not grammatical at all. However big the layer is, that's how much memory you're taking up. So if you have a view that's the size of the screen and you're going to make it a layer, That's fine on a temporary basis, but you don't want a screen-sized buffer sitting around in texture memory full-time taking up all that memory, because that's memory that the rest of your application, the rest of the system cannot have as long as that layer is sitting around. So don't take up the memory full-time, and also don't make us recreate the layer. If you create a layer on an object and then you cause drawing operations that make us recreate the layer, bad thing. Not only are we recreating the layer, which is really expensive, but we're also drawing to a layer and then copying to the screen. So we're actually doing more work every time we recreate the layer on every frame. So do it only for situations where you're not recreating it, and do it temporarily, like during an animation. And we'll see a little bit of code later for how you can do that. We'll see a little bit of code later for how you can do that. See the previous sentence? Okay. Charge your GPS before you leave the harbor, or else you'll, I don't know, get lost, I guess. Don't use too many views on the Android side. Basically, make sure your hierarchy is only as complicated as you need to. There's so many applications that I see in hierarchy viewer where they will have a string of layouts, one after another. They got a frame layout here, and that's a parent of a single child that's a linear layout, which is parent of another linear layout, that's a parent of a custom layout, that's a parent of a... Why? You could have put that all in one view. More than that, you can actually collapse entire view hierarchies into custom views when it makes sense. Calendar is a really good example of that. They had this really complicated view situation, this hierarchy to handle this situation where they needed text up here and they needed a custom color down here, and then they had this little button thing done, and there was lines, and it was just this explosion of views. And what they did was rewrote it as one single custom view. And then the drawing code in OnDraw can take care of how to actually render that thing. And you can process your touch input however you want, right? So there's a little bit of custom code to make this work, but in some cases, that's the right choice because it can simplify a really complex view hierarchy for you. On the pirate side, remember where you buried your treasure, or else, obviously. On the Android side, be careful with alpha. So this relates to the overdraw thing I talked about before. Every time you draw a pixel, it costs you. That means that if you're drawing an opaque background and then you're drawing a transparent object in front of it, you're going to draw opaque first, then you're going to draw transparent on top of it. And sometimes that transparent pixel costs a little bit more because it needs to read the color behind it, process it, blend with it. Not only that, but sometimes the alpha operations cause us to go create an external bitmap or an external buffer, draw into that buffer, and then copy it over. So alpha tends to be expensive. That doesn't mean don't use it. That's not what I said. It's a fantastic effect to use, usually on a temporary basis, fading things in and out. One of my favorite performance situations was in, let's call it Jelly Bean, where the notification panel that you would pull down from the top was taking way too long to draw. We were missing the 60 frames a second. We were hitting like 30 on a good day. And it turned out that someone really wanted gray text in the notification items. So they created a black text color, and then they made that text view translucent. They said, oh, and assign it an alpha value of 70%, which meant that every time we drew the text, we would create a buffer, we would draw it out to the buffer, and then we would copy it back translucently. Cost a lot of time and effort to get what they could have gotten if they just said, oh, by the way, give me gray text, which was the right approach. So be aware of alpha. I didn't say don't use it, but be aware that it does cost. Don't tell the others where your treasure is buried, or you'll have a bad time. On the Android side, reuse your rendering objects. This is kind of a tip about GC in general. If you're in your onDraw command and every time you hit it, you do a, hey, give me a new paint object. By the way, create me a bitmap. Do the following thing. You will stack up temporary objects that need to be GC'd eventually, and that does cost time. It doesn't cost a lot of time, but it will cost enough to cause a hiccup eventually, which means you could be in the middle of the animation when all of a sudden the garbage collector says, hey, I need some more space, stops the world, collects the space, and then you go on. And in the meantime, the user saw a hiccup for a frame. So what was a really nice swooshy animation across the screen jittered in the middle because they were collected, the garbage collector was taking care of all the temporary paint objects that you allocated. Instead, hey, why not keep a temporary one around? You create it once, you reuse it in your draw method. We didn't need to create a new object along the fly. Always wear your sunscreen, or you'll have a bad day. Don't modify your bitmaps often. So whenever you use the Canvas APIs in Android, that turns into GPU commands. and parameters and operations. And in the case of bitmaps, it turns into a texture map, right? So you have an image, you're going to create the bitmap, you're going to draw into it, you're going to, whatever, copy your resource into it, and then we're going to upload a texture so that we can then copy that texture around in GPU memory. All of that part's good. But then if on every frame you say, oh, and by the way, I want to draw into my bitmap again, then we say, okay, we can do that for you. So we're going to draw into the bitmap, we're going to upload the texture. Next frame, we're going to draw into the bitmap, we're going to upload the texture. That costs a lot of performance and effort. Sometimes it's necessary, but you need to be aware of it. Just like all these tips, it doesn't mean don't do it, but be aware of it and be doing it for the right reason. Because you don't want us to go to effort on your behalf if we didn't really need to. For the pirates, only attack the ships with treasure, or you'll be a poor pirate. For the Android developers, don't modify your paths often. So this relates to the bitmap point on the previous set of slides. To draw paths on the Android platform, we use software rasterization. We create a bitmap, we draw a path into it, and then, just like I was talking about before, we upload that bitmap into texture memory, right? So let's say you're animating a path. Great, looks great on the screen. That means that on every single frame, we go to the software rasterizer, we have it draw into a bitmap, we upload the texture. We draw into the bitmap, we upload the texture. Draw into the bitmap, upload the texture. Slow, right? It's possible, and if it's the right thing to do for your application, that's fine, but be aware of it. If you don't need to modify the path, if there's another way to achieve your objective, that's probably the right approach. Don't wear your patches on both eyes, or you'll have a bad day. Profile your application, and then when you're done, profile it again. And you might want to do it another time as well. Use the tools that I talked about today, and use any other tools that you want. My personal favorite tool is system.out.println. It works. Unfortunately, a lot of the coding that I do is in animations, and it's kind of hard to do a step debugger to figure out what's going on with the timing of that animation. So I end up issuing a lot of print lines into the log, and then taking a look at the log, and take a look at the time that this thing happened. That works as well. Do whatever you need to see where the bottleneck's in your application. Don't just say, gee, that looks really bad. Figure out why it looks bad and see what you can do about it. See if you're actually running layout during every animation frame. If you are, do whatever you have to get it out of there, because that is going to cause problems forever, right? Do whatever you can to trim down the amount of time that you're spending on every animation frame to make sure that you can always hit under 16 milliseconds per frame or 60 frames per second. If you're a pirate, don't attack the entire fleet, or you'll all have a bad time. If you're an Android developer, do less stuff. We optimize all the time. It's one of the main things that we do in my group, the UI Toolkit group. We spend a lot of time figuring out how to make things go faster, how to cut out the time from all these operations, how to optimize the hardware rendering, the hardware accelerated path. We're doing stuff all the time to make applications faster, but we can only do it on a very generic level. We can do it framework-wide and make decisions about things that applications in general are doing, but we don't know your application as well as you do. Turns out that you know that better than we do. So do whatever you can do in your application. We can't cut out that layout for you. If you tell us to run layout, we're going to run layout, right? But you know when you actually need to run layout and when you could actually set that aside and run it later to make sure that it doesn't happen in an animation. So I'm going to do a time check. Do we have any idea how much time I have? I have 7 minutes. I have time for a demo. Yay. All right. So we're going to talk about overdraw. I'm going to see if I can get the Wolf Vision to work. Let's see. Everybody see that? Squint. Squint a lot. What am I supposed to do here for the Wolf Vision? I did. Anybody in the back of the room? Hi. Anybody in the back of the room that knows what's going on here? I'll just hold it up really high. Okay, all right. The experts are on their way. Okay, so let's assume that we've run this demo. It's really awesome. It's a pretty basic application. Oh, come on. Well, okay. You know what? There we go. Expert, yay! What am I missing here? Yep, 3. Oh, turns out the wire had to be plugged in. You're right, it was a wireless problem. Yeah, could everybody turn off their wireless, please? This demo is not up to this level of preparation here. All right, so while we're working on that, I think I'll talk about the code. So the situation is I have a very simple application. It has a background, it has a couple of buttons. Turns out the window has a background because the window always has a background in the default theme. Hey, there we are. Oh no, now you're gonna see my password. All right. All right, there it is. So we have a window, we have a couple of buttons. And then I'm going to show you how to see some overdraw stuff. Let's debug GPU overdraw. We'll show the areas. So you see some colors-ish on the screen. You can sort of see a blue tint here. There's a green tint down there. If we go back to the application that's white, it's going to be a little bit easier to see this. So you can see this used to be kind of a really light or white gray, and now it's blue, and those are green, and the text is actually red, which you can't see very well on the screen. And what's going on is we're drawing a window background, and then we have an opaque layout sitting right on top of it. So the main layout in my application has a background color, which is pretty typical, right? So I had this light gray background color there. So we're drawing the window background, and then 2x overdraw. We're drawing an opaque background right on top of it. So there we go. Ooh, look at that highlight. Isn't that beautiful? So there's an easy fix to this situation that's typically recommended, which is go ahead and remove the window background. If you're just going to draw an opaque color directly on top of the window background, why do you even have a window background? So this is an approach that I've seen a lot of people use on the web. If you go to Stack Overflow, this is common. And they say, well, just set it to null in your theme, and then go ahead and use that theme, right? So we'll use that background theme, and we'll have a null window, and that's, it's going to work really well. So if we go back here, let's see how well it works. So let me disable GPU overdraw. And go back here, we'll swipe that out of the way, and we'll say, okay, now look really closely. Ready? Did you see the black window? Let me do that again. It's really cool. Okay, as the window came up, it was completely black. Probably not what you wanted, right? But the trick is that the window manager wants to animate your window in. You launch an activity, it's going to animate that activity in. But it wants to do that before it calls layout for the first time. It doesn't want you to go through your creation code, spend a lot of time going out and querying the web and doing whatever silly things you want to do during creation, because then it's just going to be frozen waiting for your application to come back. So instead, it's going to make some very quick decisions about what to do and say, well, what color is your theme? I'm just going to draw that, and we're going to animate the window in, and then we'll call your creation code and get on with real life. And in the meantime, you said, oh, by the way, I don't have a background, and the window manager just threw up its hands and drew whatever it could. And on most devices, that ends up being black. In some situations, I've seen it be garbage because it really doesn't know what to draw, right? So what you want to do instead is have something like this. So we'll draw the other version of the application. I call this one empty background instead of null background. And you can see as it animates in, it's actually got a decent background. So if we go back to the slides, we can see the code that you shouldn't use and the code that you should use instead, which is go ahead and keep your opaque background on your window. And then in your creation code, if you're in this situation, you want to get rid of the window background, go ahead and do it dynamically by setting the background drawable to null during your onCreate call. So window manager has finished the window transition. Now you're in onCreate. Go ahead and get rid of it if you want, if that's the right thing to do. We have 2 minutes. Really quick one about hardware layers. So we talked about using hardware layers. I could show you the overdraw in that demo, but let's not. So we have a situation in this other really simple app I wrote where we have a scroll view. It's got this container in it, and then it has another container with rows, and you got buttons in there. And every time I click a button, we're going to fade in and out the scroll view, right? So this is a really complex hierarchy potentially, so why don't we go ahead and set a layer on the scroll view, and we'll get better performance for it. And we can do that. Okay, here's the fading code. We're using view property animator. We're saying fade it out. When it's done, fade it back in. And turns out performance is not great because it's a really complex hierarchy. So somebody told me I should use a hardware layer. So I'm going to do that. I'm going to set a hardware layer on the scroll view, and then performance is going to rock. And it turns out that It does for this particular situation. So if we take a look at systrace output, this is one of the performance tools I talked about. You can see in this situation, before the layer, we were taking about 7.5 milliseconds per frame to draw that hierarchy during the animation that was fading it out and then back in. And then we turned on a layer in the scroll view, and life was magical, right? All of a sudden, we've got 3.5 milliseconds, like less than half the time, because it's really fast for us to simply copy textures around. That's great, until you go to scroll the view. And then something else comes up. You're like, well, every time I scroll, it used to take 7.5 milliseconds, and now with a layer, it's more expensive. So what's going on? Two things. One is that you told us to create a layer permanently. Bad thing, right? Because now we're taking up all this memory just sitting there all the time for this one scroll view. Not only that, but every time we draw it, like every time we do a scroll, we actually have to recreate that layer because something inside of it got invalidated. And that's why it takes more time. And you can see the culprit here is we're actually calling update layer. We're recreating the layer on every single frame. So a better approach, instead of creating the layer on the scroll view, do it instead with view property animator and say, when the animation is started, give me a layer, and that's it. And we take care of it for you. We put a layer on at the beginning, we take the layer off at the end. So use hardware layers, please, but only use them temporarily. And that, me mateys, is the end.